Hello and welcome. This is a follow-up to an integral that I've done very recently, which you see up there. I'm going to try to actually put this lecture straight after or possibly put a link to this integration to verify the answer that we got by differentiation, because it's actually quite a nice answer. I wrote it as y is equal to. So basically when we integrated this particular integral, I put a plus c there. Obviously that's the two answers that we obtained, two variants, they're practically the same answer, and we're going to verify that this differentiates, of course, to the integrand that we got up there, and this requires further maths because, of course, quite clearly we're going to need to differentiate an arc sine, but other than that, it's just quite a challenging manipulation of something which looks very messy. Try to simplify it and come to this form. So this is our target. It doesn't really matter which one we're going to differentiate. This is practically the same. All it is these two terms, we factorize the 1 minus x out of it. So probably I will use the number 2. It will hardly matter. So we're gonna say if y is that, show that the y by dx is in fact that. And the integral, as I just mentioned, we've done it the other day. So I'm going to go straight to the differentiation. So dy by dx is equal to, it might be worth putting up there, write this perhaps all in index notation. So minus 1 minus x to the power of a half, multiplying 2 plus x to the power of a half, minus the arc sine of 1 minus x to the power of a half. When I look at this, rather than going straight to this differentiation, we clearly have a product here to deal with, and we have a kind of like a messy chain when it comes to the differentiation of the arc sine. Since we have this term appearing twice, this of course is inside the arc sine and is part of the product, and at some point when I need to differentiate it, it might make sense to do some side workings and first of all have ready the differential of 1 minus x to the power of a half. So when it comes to use it in two different places, is ready, we'll just copy it from there. So that's going to be equal to a half coming to the front, 1 minus x to the power of minus a half, times the minus 1 from the chain of the minus x. So that is that. So now I can use that. It will save me a little bit of the tidy ups and recopying a few lines just to tidy. Okay, so I'm looking at this line here now, and let's not forget we have minuses there, which is going to make the life very painful. So we're dealing with this product. The product of that, we have a minus, and if we differentiate the first term, which is this, we're going to get, of course, that quantity there. And because I got a minus, I'm going to switch into a plus, and I'm going to write a half, 1 minus x to the power of minus a half, times the second bracket untouched, 2 plus x to the half. Now I need to do it the other way around. Because I got a minus, the plus of course of the product rule will stay as a minus, minus, leave the bracket 1 minus x to the half untouched, to the half, and now differentiate this bracket. Of course this will differentiate to 0, and the x to the half will differentiate to times a half x to the power of minus a half. That dealt of course with my product. And now I have to deal with the arc sine. Arc sine differentiates to 1 over, the minus of course is because it's there, the square root of 1 minus the square of its argument. So that bit squared. So 1 minus the 1 minus x to the half all squared, which of course is going to be minus 1 over x, which will in fact will simplify to 1 over the square root of x. I'll just write it here, so I'll just do it on the next line. Let's do it on the next line, otherwise we're just cutting out a lot of the workings, times the differential of its argument, and of course the differential of 1 minus x to the half, we've got it in here. Careful, because you're going to have to use a bracket. minus a half, 1 minus x to the power of minus a half, close bracket. So now we need to do a few tidies. Okay, what can we do? Can we do anything for that one? Probably not. Let's leave it till I see the rest of the terms as well. 2 plus x to the half. For this particular one, again, all I'm going to do is move the half at the front, this half here. The rest I'm just going to leave it as it is. X to the half, x to the power of minus a half. And the main tidy up is going to be in this bit here. First of all, minus and a minus will go plus. Now, this is very annoyingly painful there how I wrote it. So this is the half I've taken care of. Next, I'm going to have this bracket here. 1 minus x to the power of minus a half. I'm going to have to move that off in a minute because it's very annoying. And this 1 minus 1 will cancel. Minus minus a plus. So there's 1 over the square root of x, which of course is x to the minus a half. So that's this bit here. X to the power of minus half. I hope we can see that. Let me just write this a little bit neater because it's in the same neighborhood as the other one. There might be a fight in a minute. So 1 minus bracket 1 minus x, like that. Okay. And I lost the half somewhere along the line. I said plus a half. Let me just, I lost the minus there as well. Minus the half, positive. That's this bit here and that's that bit there. Okay. So far, so good. Now we need to somehow tidy this into something which looks like that. Obvious things to do. Well, the half is obvious, is asking, can you please factorize me? Is there anything else that's asking for similar things? This bracket appears in 3 places, but unfortunately is not in the same power. We got minus half, and half here. We're going to pull it in its lowest power to the minus a half. Let's just stick to that and see what happens with the rest. So big square bracket, and let's be careful to make sure we got all the bits that we need out of that. So this is now the half, and what I'm writing is there is 2 plus x to the half. The bracket is not needed because it's plus and everything else has gone outside. So that's this bracket here. We pulled half or minus a half. We pulled out a half, therefore we have a minus in there. We definitely have the x to the power of minus a half still there. That's this bit here. From this bracket, because we pulled it to the power of minus a half, we have 1 minus x to the power of 1. Watson, just check. If you multiply those two, the powers will add to positive half, which is correct. Of course, the 1 is not needed there. It's just a nuisance. I'm going to take it off. And lastly, I have a plus. The half has gone out. This bracket has gone out. And I've got an x to the power of minus a half. So far, so good. Let's see what happens now with this particular bracket. Shall I just rewrite it? Or because I put an extra big bracket there, perhaps, I'm going to write underneath in red pen what I've got left in there. I've got a 2 plus x to the half. This bracket now can be multiplied. So it's going to be minus x to the power of minus a half. And minus times a minus is a plus. X to the minus a half times x to the 1 is x to the half. Plus x to the power of minus half. Hopefully no mistakes. Let's go and see what happens. Equal half 1 minus x to the power minus a half. Okay. What happens there? Anything cancels? There's a minus in there. So that's the minus. Anything to get rid of? Yes. That and that goes. So what simplifies there? We got a 2. And that's exactly the same. Plus 2 lots of x to the half. That's not bad because, of course, 2.5 can be simplified. So just a very small step. Let's rewrite that as, let's do it in steps. So we got a 1 plus x to the half. That's the 2 factorized out and getting rid of this half. Times actually, I'm not going to put, let's put the times. I will do it on the next line. Times the bracket 1 minus x. I was going to write to the bottom as a square root, but I don't think I can fit everything I want perhaps here, and I don't want to take a chance. I'm going to do some rubbing and go to the top. So let's go back to the top. And this looks simple enough. The question is, just at first glance, is not what I've got, but having done the integral beforehand, I know this is how I'm going to go from this line to this line. Normally, if we were just be given with this differentiation, it might be a little bit difficult. Most of the marks will be up to there, but it might be a bit difficult to see what to do next. So this is now how far we got it. So this is now 1 plus the square root of x, that's this line here, over a negative square root at the bottom. So at first glance, we might be thinking, well, we probably made a mistake in there, because that kind of looks like what very, very similar to what we got in there, but not quite the same. So our first thoughts will be probably a mistake. But of course, we need to do a couple of more steps. And the first step is to multiply top and bottom of this fraction by the conjugate of this numerator. Okay, so that's the first step. And you will see what happens. So that's a 1 minus the square root of x. So top and bottom by this quantity. Of course, on the top, I've got a difference of squares. So it's going to give me a 1 minus this quantity squared, which is just simply x. Not quite the square root of x, as you see in there, but perhaps we'll have to try our luck. But if we look closely, we already have on the denominator exactly the same term, but to the power of a half. That's this bit here. And I think we are done, because that is, of course, 1 minus x to the 1. Perhaps I'm insulting your intelligence by even writing this. And that's, of course, to the half. And, of course, that will move the square root on the top. So that will be 1 minus x square rooted over 1 minus the square root of x. That bracket is not needed, and I hope you can see the cancellation there, rules of indices, and that will go to the half on the top. And of course, that differentiation has been verified. Okay, an interesting question, quite challenging as opposed to, it's a little bit kind of messy to keep a cool head and walk through all this kind of stuff, but we did do the integral, we got this answer, we verified it, we're very, very happy, and I'll see you very soon. Who's laughing now?